So in this video we will be seeing how to create the calculator shellcode. So for that we are going to create the process calculator.exe using CreateProcessA function. So at this point we have seen how to retrieve the NTDLL base address, and also I have written what we have done in the previous video. So in the previous video we have seen how to parse the function address from the base address. So what I have done is I have created a new stack frame and everything else is the same. Everything is same, and I have added some epilogue so that this will be acting as a function, so we can directly call this function with appropriate parameters. So the first parameter will be the base address of DLL or PE file, and the second one is address of function name, and the third parameter is the length of that function name. So these are the three parameters this function will take. So you can see here EBP EBP plus 8, you can see here. EBP plus 8 is the base address of this DLL, NTDLL we are going to pass. So in the CreateProcessA function, the total argument size is 40, and you can also see the bool value which should be 1 byte, but you cannot push the 1 byte onto the stack, so it is also considered as a 4 bytes. And again we are going to subtract this 10 and add the 18. Now we need to read 4 bytes from here. So now EAX should point to the kernel base.dll base address. Okay, now we have got the kernel base.dll base address. We need to find the address of CreateProcessA in the DLL. So we are going to use our getExported function which we have written in the previous videos. So the first, we need to convert this string into ASCII characters. So CreateProcessA and separate these by 4 bytes. So we are going to push these bytes in the reverse order, and also because of Little Indian byte order. So first let's push 41, 73, again push. So we have pushed these 4 bytes, again push 6574, and push 'So let's XOR ESI comma ESI, and so these are on the top of the stack. So the ESP points to the address of directory contains these bytes, so we can push ESI and move the ESP value into ESI. So ESP is directly pointing to this contents, so you can just copy the ESP contents into ESI, so that ESI contains the address of the CreateProcessA. Now we are going to call this function. So the first parameter we are going to push is the length of the function name. So push 14 and push the address of the function name, that is ESI, and push the dealer base address we want to parse from, that is the EAX. Call get exported function, and the return value will be stored in EAX register. And also we need to clean up stack because we have pushed the contents. So we have pushed 4, 8, 12, 16, 18 bytes. So push 18, add ESP comma 18. So we are just dereferencing the ESP, we are adding the ESP 18 bytes. And also let's okay, we already figured the address. So 757.8b5e0. So 8b5e0 should be the address of CreateProcessA. So EAX contains this 7558000, that is the address of kernel based DLL. And let's ESI now contains 0. Let's push onto the stack. So 0 and pushing this last bytes. So okay, we made some mistake. So automatically we are pushing only 2 bytes here. So let's remove this and push from here onwards 61657243, and push the next 4 bytes in the reverse order. So now we are pushing only the 2 bytes 4173, and you can also push the 2 bytes of SI. So you will push the 2 null bytes, and those 2 null bytes will be added to at this 2 bytes. So I think we are good to go. So let's see this. Push SI, only 2 bytes will be pushed. So here you can see the 2 bytes. Now we are pushing the last 2. So CreateProcessA. So here you can see the CreateProcessA. So these are aligned with 4. So we are pushing the 14, the length of the string, and push ESI and push EAX, and now let's continue. And EAX contains the 8x580, which we have seen the address of CreateProcessA. So the process also exited normally. So now EAX contains CreateProcessA function address. Now we need to just pass the parameters of CreateProcessA and call that function. So application name can be null, and the command line we are going to pass calculator.exe, and process attributes null, thread attributes null, inherit handles 0, that is also null. Whether to specify our child process should inherit our handles or not, and creation flags 0, environment 0, current directory 0, and startup info. So for the startup info we need to specify one structure member, that is CB. So in this structure we need to specify the size of startup info A structure, and let's calculate the size of the structure. 4, 8, 6, 12, 16, 20, 24, 32, 36, 40, 44, 48, 52, 54, 56, 60, so let's calculate how many are there with 4 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 fours 64, and 2 bytes, 2 bytes, 4 bytes, so 68. So 68 is the total size of the startup info structure. So we need to create the 68 null bytes onto the stack and make the starting 4 bytes value as 68. So we can loop over this ECX comma. So 68 by 4 gives us 16, I think it's 17, I guess. So 17, and push the 4 bytes of 4 nulls. And loop instruction, we can use loop instruction, so it will automatically decrease the ECX value until 0. So now we have pushed 68 null bytes, or we can say 64 null bytes, and now there are 4 bytes we need to push. We can say push 68, that is the value of the CB member, the total size of the startup info structure. Okay, now we need to copy the ESP points to the top of the stack always, so we need to copy the ESP into the ESI, so that ESI have the address to this 68 bytes. And the next member we want to initialize is the process information structure. So this is the return value from the function. So we need to pass 16 bytes, so address of 16 null bytes. So the function will fill with process handle, thread handle, process ID and thread ID. So we need to loop over this again. So we have created the 16 null bytes, and the address will be the ESP the top of the stack. Move EDI comma ESP. So EDI points to process info structure. So we have initialized all of our structures. We can pass from left to right, so right to left, so from backwards. So you can see the process information we have just pushed onto the stack or the contents. So we can just remove this one, and we can directly push the ESP value, because the ESP already contains these 16 null bytes. So process information, and now we are going to push the address of the startup info A, that is we have stored it in ESI. Startup info A, and we can pass null bytes. We can pass null 1 2 3 4 5 6. Push EBX. Now we need to pass the address of the command line. So we need to pass the calculator.exe again. So we need to convert this into ASCII characters. So let's store this in EDI, push EDI, and push these bytes in the reverse order. And 63, 6C, 61, 63H, and move EDI comma ESP. So you can also see the ending is the null bytes. So make sure you have one null byte at the ending of this calc.exe. So push edi, and now we have everything is ready. All we need to do is call eax. So eax contains the address of this CreateProcessA function. So let's see all of this, how this will run. So let's put the breakpoint here. So pushing 0 and pushing character.exe and pushing the pushing the 64 bytes. So here you can see the 44 is the hexadecimal of 68. And this address F784 is stored in ESI, and push ESP and ESI. So let's put another breakpoint at this and continue. And here you can see the arguments. The first argument is application name, which is null, and the command line address, the F7C8. So F7C8. So it is down here, F7C8. We have the character.exe, and the last two are startup info 84. You can see the 84 points. The first member is CB, which points to the size of the structure, and the last one is the startup info, which is next to the stack, 4 rows of null bytes. So if I go and run this, we should see the calculator popped up. So you can see we have successfully executed CreateProcessA function from the kernel base.dll. So you can also clean up the stack. So we have push. You don't need to take care of these pushes because the Kali CreateProcessA will take care of this, of these arguments only. So we need to still clean up these pushes we have made. So 4 into 4, 16 plus so actually I think 1 should do here, my bad. Yes, so we are passing 4 bytes here, and 4 bytes, 8 bytes, and 16 into 4, 64 plus 8, 72, 72, 76, 80, 84. So I think 84, add ESP comma 84. So if I go and continue, we should exit gracefully. Okay, and we are good to go. So that's how you can create the calculator shellcode. You can also execute any other process as well using the CreateProcessA function.